In this video, we'll be talking about joint variation. Joint variation is when you have more than two variables that vary. An example would be y varies jointly as x and w squared and inversely as z if y equals k times x times w squared divided by z. Notice that the inversely part indicates that we have to divide by z. Otherwise, everything else is in the numerator multiplied, and we still have that constant of variation that we use k. For an example of joint variation, P varies jointly as Q and R squared and inversely as S. This first part of our problem is what we'll take our equation from. P varies jointly, so P equals K times Q times R squared, and inversely as S. This is our equation that we'll be working with. Then we're given our information. When Q is 2, R is 3, and S is 5, P is 200. So now we have numbers in all the spots except for K. We can solve for K. This 200 is equal to K times 18 over 5 multiplied by the reciprocal. So it looks like K is 500 over 9. Now we can put that K value back into our equation. We have P is equal to 500 over 9 times Q times R squared all over S. And then finish our problem. Find P when Q is 5, R is 2, and S is 2. So I'm going to cancel this one of these 2's with one of these. And I have P is equal to 500 over 9 times 10. 5 times 2 is 10. I no longer have this denominator. And so it looks like P is equal to 5,000 over 9. Another example. X varies jointly as y squared and z cubed. So our equation is x varies jointly as y squared and z cubed. Notice we don't have any inverse variation in this problem. So this is all I need to get started. X is 16 when y is 2 and z is 1 And now I can solve for k. 16 is equal to k times 4. Divide both sides by 4. So k is 4. Now I can put that back into my equation. X is equal to 4 times y squared times z cubed. And then I can finish my problem. Find x when y is 1 and z is 2. So x is equal to 4 times 8. X is equal to 32.